Okay, here's a lesson on electron dot structures and Lewis structures. So first we're doing a little review here, single elements, just drawing the dot structure, so following atoms. Hydrogen, so hopefully you have your periodic table out. Hydrogen has one valence electron and one total electron, so its dot structure would just look like that. Where you put the electron doesn't really matter in this case. Helium has two, and so we're going to put 2. And when we draw the electrons, they usually form in pairs, so I'm going to draw them next to one another. If you had drawn that pair up here, or over here, or over here, it would be all the same. Boron has 3, so we have 2 in a pair and 1 sitting by itself. They're not going to form up in like a group of 3. You'd have a pair and then a single one. Nitrogen has 5. So we draw the chemical symbol. We have 1, 2, 3, 4, and 5. Carbon has 4. 1, 2, 3, 4. Neon, noble gas, has 8. So it will be inert, meaning it's very happy. It doesn't want to give away electrons. It doesn't want to take in electrons because it has this full octet, a full shell of 8 valence electrons. So it doesn't react with other atoms very much. Fluorine, on the other hand, has 7 valence electrons and so definitely wants another electron. So its Lewis structure, or dot structure, will be 1, 2, 3, 4, 5, 6, 7. And again, where I drew these, on which side they go, it doesn't really matter. Xenon, yet another noble gas. 1, 2, 3, 4, 5, 6, 7, 8. And phosphorus looks like 1, 2, 3, 4, 5. So we have P, the chemical symbol. 1, 2, 3, 4, 5. Okay. So that's the basics, drawing dot structures for individual atoms. And again, the dots represent the valence electrons. Now, when we're talking about a molecule, so multiple atoms joined together, and here we will just be dealing with single bonds. It goes like this. For H2, we have a hydrogen and a hydrogen. And so what I'm doing here is I'm adding up the total number of valence electrons. We have 2 valence electrons. And so I can start by drawing like a primary structure or whatever, where I have the 2 hydrogen atoms and I'm going to draw a bond between them. And I know that that bond represents 2 electrons. I know that looks like a division symbol, but it's not. So 2 electrons shared, we could say that this is from this hydrogen, this is from this hydrogen. So each hydrogen feels like it has 2, which would complete its inner shell. And so the actual structure looks like that. For H2O, I'm going to do the same thing where I add up all the valence electrons. H is 1, O is 6. Giving us a total of 8 valence electrons. And so I assume oxygen is going to be in the center with hydrogens outside. When you see something like this, where there's a bunch of these surrounding one of these, usually this is the central atom, just like down here. Carbon's going to be the central atom and the chlorines will be around it. So oxygen has 6. 1, 2, 3, 4, 5, 6. Notice how what I just drew is different from what we had above, okay? I kind of know that one of these is going to go with the hydrogen and one of these is going to go with this hydrogen. So that's why I drew it this way, okay? 2 lone pairs of electrons, and then these electrons sitting by themselves. So for the hydrogen, I'll draw this in blue, hydrogen atom, we have this electron from this hydrogen, this electron from this hydrogen, okay? And these little bubbles that I'm drawing, this is just for instructional purposes. You don't actually draw that. Notice how oxygen feels like 1, 2, 3, 4, 5, 6, 7, 8. It is happy. And hydrogen, which wants 2, because it only has the primary energy level or first energy level, 1, 2, and 1, 2. So this is a bond, this is a bond, and it would look like this. Oxygen bonded to the two hydrogens with a lone pair of electrons and another lone pair of electrons. NH3 or ammonia, hydrogen, 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 and nitrogen. We're going to add them up. 1, 1, 1. Nitrogen is 5, giving us a total of 8. I'm assuming that nitrogen is in the middle. H, H, H. And so I know that because each of these hydrogens, I'll draw them first, each of these hydrogens has one valence electron, it's probably going to be an electron from the nitrogen, an electron from the nitrogen, an electron from the nitrogen. So this time we'll draw nitrogen in blue. And I'm going to put 1, 2, 3, and then I have left over 4 and 5, which is good because these are in a pair. It's more stable that way. I think I'm correct. This is a bond, this is a bond, this is a bond, and counting up each hydrogen, because they're sharing, has 2 next to it, and the nitrogen has 1, 2, 3, 4, 5, 6, 7, 8. Good. So it would look like this. Hydrogen, hydrogen, and hydrogen all bonded to the nitrogen with 1 lone electron pair off there. Number 4, CH4. Adding them up, C, H, H, H. 4 for carbon. Oops, and there's another H and 1 each for these guys, giving a total of 8. So carbon looks like the central atom. I'm going to draw this for each of the hydrogens. And then the carbon. So it has 4 electrons to spare, and we're going to just start pairing them up. We know we'll have 1 there to make a bond, 1 here to make a bond, 1 here to make a bond, 1 here to make a bond, and all of a sudden, all 4 of them are used up. We have 4 bonds. If you count up the electrons for carbon, 1, 2, 3, 4, 5, 6, 7, 8, and it will look like carbon, hydrogen, 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 and hydrogen. Okay. We're going to do the same thing for carbon tetrachloride. Carbon, Cl, 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 and Cl. So we have 4, 7, 7, 7, 7. Adding all those gives us 32. So we know that when we're drawing in the electrons, we should have a total of 32. Carbon is in the center. Chlorine we'll put off to the sides in a little square pattern. And this time I'm going to draw in the electrons for carbon first, assuming that 1 will go here, 1 will go here, and 1 will go here. Okay. And then for chlorine, we know we have 7. So if I go 1, 2, 3, 4, 5, 6, 7, looks like it's going to work. We have 1, 2, 3, 4, 5, 6, 7, 8 for chlorine, and the central atom carbon, if it has 2 for each of these, is going to have a total of 8 as well. So let's fill those in. 1, 2, 3, 4, 5, 6, 7 for chlorine. 1, 2, 3, 4, 5, 6, 7. And I'm doing this because chlorine has 7 valence electrons. 1, 2, 3, 4, 5, 6, 7. Okay, so if we count them up, 8, 8, 8, 8, and 8 valence electrons. everybody's happy. These are the bonds, and the Lewis structure would look like this. Okay. 6, CCl2Br2. So it still looks like carbon will be the central atom with the chlorines and bromines sticking off the side. We're going to add up Br and Br. 4, 7, 7, 7, and 7 again, giving us a total of 32. And so carbon and chlorine, chlorine, bromine, bromine. The central atom carbon, I'll draw its valence electrons first. We have a total of 4. And then using a different color, let's see, for the bromine, 1, 2, 3, 4, 5, 6, 7. For the bromine, 1, 2, 3, 4, 5, 6, 7. And similarly, 7 each for the chlorines. And we have voila, 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 voila. Okay. Bond, 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 bond. And you know what I forgot to do? So let me show you. We have chlorine, we have bromine, and we have bromine. And I forgot on the previous example to draw in the lone pairs. So lone pair, we have 3 each on these guys that I forgot to draw in. So in a Lewis structure you draw the bonds, but you also draw the spare lone pairs. So back here, I know this is getting a little messy, but in this answer right here, I should have drawn the lone pairs, getting a little ahead of myself, 3 lone pairs around each. So all of these 32 electrons are shown, okay, either as a bond, where each bond is 2 electrons shared between the atoms, or as a lone pair. Okay, so I'm going to put this on pause and let you work through number 7, 8, and 9. So do that now, and then check your answers in part 2. Thank you.